Hi, we are Quadtech Engineering and we have been tasked with designing a citrus juicer for health club and gym fitness zone.
Hi, my name is Nick Ramya. I contributed to the project My Organizational Skills in Microsoft Office, calculations for tables and aided in choosing the final design.
Hi, my name is Carlos Mike, and I contributed my thorough research skills as well as my proficiency in computer-aided design software and Microsoft Office. I developed concept 2 and I aided in the design process.
My name is Ariadne Sipasad. In this project, I contributed my organizational skills as well as my effective report writing. Additionally, I aided in the final design process as well as I developed concept 1.
Hi, my name is Dinesh Daniel. I brought my audiovisual expertise to my group as well as my analysis skills. Additionally, I was responsible for design 3, which has been chosen as the final design.
Here is some background information we researched before beginning our project. Citrus fruits vary in sizes from 3 cm to 10 cm in diameter. They all contain seeds, pulp, and juice. Limes, lemons, oranges, Portugals, tangerines, and grapefruits are frequently consumed as juices, mixed or alone. Commercial citrus juices typically have a pulp and no pulp option. Hence, when designing a citrus juicer, a filter is important to give the option of pulp or no pulp. Citrus juice is acidic, so citrus juicers are designed with materials that are corrosion resistant. Problem statement. Fitness zone, a health club, and gym requires a citrus juicer to make refined smoothies for their customers. Project aim. The intent of this project is to design a citrus juicer for fitness zone that will embellish the experience of making smoothies for their clients.
The objectives: to create a literature review and review patterns which will aid in the conceptualization of the design, to conduct research to determine the client/user requirements, to use the design process to create 3 concepts that we will then rate and select the best and develop them, to conduct calculations and simulations on the chosen design, and lastly to conduct a prototype which we will build.
To gain a better comprehension of a citrus juicer, a literature review was done. A citrus juicer is a device that extracts juice and pulp from citrus fruits such as oranges, lemons, limes, grapefruits, and tangerines. Most citrus juicers have a rounded ridge dome which half of the citrus fruit is pressed into, forcing juice and pulp out. Most times there is a filter to catch the seeds and or pulp if desired. Some citrus juicers are electric and or hands-free, while others are manual and require the user to spin the rounded dome into the fruit. The use of the citrus juicer depends on if the juicer is electric or manual. The fruit is cut in half and the pulp side of the fruit is pressed firmly onto the reamer. For a manual juicer, the fruit must be rotated on the reamer while pressing firmly, whereas for an electric juicer, the reamer will rotate via a motor. The juice extracted can be strained if desired. Citrus juices have a pH range from 2.3 to 11.5. Fruits such as tangerines, grapefruits, limes, and lemons have a lower pH than fruits such as mandarins, oranges, and kumquats, and therefore are more acidic. The 3 materials used to manufacture citrus juicers are stainless steel, nylon, and wood. Wood is mainly used in manual juicers. Wooden juicers can be hand-washed and they are the cheapest option. Stainless steel juicers are electronic and very ideal. However, stainless steel juicers are expensive. Nylon can be used in both manual and electronic juicers and are ideal. However, nylon juicers are not eco-friendly.
The primary objective of this intervention is to extract juice from fruit. comprising of a pair of members adapted to squeeze sections of the fruit. One of said members comprising of a rule which is a means for delivering pieces of fruit to be juiced in a single file alignment. The entire process can clearly be seen in Figure 1, where the fruit is fed from a hopper, sliced by a motor-driven cutter, and then squeezed. The juice is then passed through a spout where it falls directly into a cup. The waste is collected in a tray at the bottom of the machine.
Here we have the second pattern chosen for analysis. This was invented by Adrian Rivera and published on June 26, 2012. This is an automatic fruit juicer which turns and pushes an upward-facing juicing cone into a fruit, and this will release the juice. The juicer includes a base which contains a motor, gear, and shaft assembly. A fixed guide extends upward from the base, and inner and outer shafts reside inside the fixed guide and are driven by the motor and gear assembly to rotate and advance the juicing cone into the fruit. The inner shaft includes threads to vertically advance and retreat a shaft nut, and the outer shaft rotates with the inner shaft, but is lifted by the shaft nut when the inner shaft turns. The juicing cone releases the juice and a stationary bowl catches it.
Pattern 3. This citrus juicer has a motor-driven cone that is completely surrounded by a strainer. When a citrus fruit is pressed into the cone, the fruit juice passes through the passageways in the strainer and is collected in a bowl located under the strainer. The amount of pulp in the juice can be controlled by the adjustable annular gaps located in the radial boundary area between the cone and the strainer area. These gaps can either be increased or decreased, so either more or less pulp content will be present in the juice. There are 3 gap size selections, and these are accompanied by a self-locking thread so that the selected gap size does not change due to the vibration of the motor-driven cone when juicing.
This patent was created by European inventors. The fruit enters the top of the machine and drops in an arm. The arm rotates and the fruit is sliced by a blade located in part 4. The sliced fruit continues to rotate and enters the juicing part of the machine. This juicing mechanism is one of turning and squeezing. The fruit is pressed down onto the mechanism which then turns. The arm continues to rotate after the juice has been taken out of the fruit. The waste products are removed and another fruit falls into the arm, and the same process is repeated. This product have been designed to work fully automatic in an industrial environment or commercial environment.
The design specifications which we took into account when brainstorming our concepts are: 1. Must store enough juice for 5 smoothies. 2. Overall size of the juicer should be compact. 3. Must be able to juice citrus fruits of different sizes. 4. Easy to clean. 5. Must be safe. 6. Must not be loud. And 7. Must be efficient. Under the heading of client and user requirements, we concluded that the client will require a product which is unique, durable, easy to use, safe, stable, and efficient.
A black box shows the functional decomposition of a machine by showing its outputs and inputs in schematic form. We can see that a fruit cut in half and electrical energy are inputted into the machine. After the machine performs its functions, it outputs the juice, waste such as pulps, seeds, and shells, and also sound, heat, vibration, and mechanical energy. A transparent box shows the sub-functions of a machine to be designed. While the main function of the machine is to juice fruits, it must be able to cut and or squeeze fruits, strain and store juice. The inputs and outputs of the sub-functions are shown on the diagram.
The functional means tree shows the primary and secondary functions to be carried out by the machine as well as the means they are to be carried out in. The functions are shown by the trapezium-shaped boxes and the means by the rectangular boxes. The top level shows the main function of the system, which is to create high-quality juice. The level below it highlights 3 ways this can be carried out. There are 5 levels to this chart.
The key attributes associated with our concepts are cost, durability, the concepts must be user-friendly, size, stability, safety, and efficiency.
In this metrics table, the first column on the left-hand side is the key attributes. The 3 columns on the right-hand side are the metrics. The metrics are what are being used to measure the key attributes.
The pairwise comparison chart. This ranks the key attributes and assigns an equivalent reactive weighting. As you can see from the chart, safety and user-friendliness has the highest rating. This entails that safety and user-friendliness will be the most important when building this juicer. The morphological chart. This shows the different options to achieve a specific action. For example, turning the system on can be done by a button, switch, or voice control. Another example is the energy source, which can be electrical, batteries, or solar powered. The best option will be chosen.
Concept 1. The citrus fruit is cut in half and placed under the dome, skin side up. The juicer is turned on by plugging it into an outlet. The inside of the fruit is then pressed onto a ridged conical dome located under the dome, and the handle is pushed downward. This activates the motor to rotate the ridged conical dome, which presses and rotates into the fruit. The juice expelled from the fruit falls into a sieve located in the container lid, and then into the container. The sieve can be adjusted so that no pulp or pulp will be present in the juice. The container holds 30 ounces of juice. The tap can then be opened and juice is released into a cup placed in the cup holder. This concept allows for 2 citrus fruits to be juiced at once.
Here we have the second design concept, and this is an automatic fruit juicer made up of a stopper, covering lid, bowl with sieve and cutting blade, drain, motor, juice collector, and waste bin. The main materials used in this concept are stainless steel and clear plastic. Firstly, fruits are inserted into the juicer at the top and pressed firmly using the stopper. These fruits enter a bowl in which there is a cutting blade at the base and the sides have small holes so it functions as a sieve. The bowl is spun by a motor connected via a shaft. The motor is situated under the bowl. Juice will exit the sieve and then flow out into a container. This is the juice collector via an opening. This is the drain. Waste exits the bowl over the top and into another container. This is the waste bin through another opening. Both collecting containers are removable.
Concept C. The fruit enters one at a time through a funnel. They are then crushed by the gas seen through a transparent window. This is the means of extracting the juice. The juice then flows through the holes at the bottom of the container, entering the strainer. Then it enters one of 2 pipes, which is controlled by the user, and flows into one side of the split container. The juice is stored until dispensed by a tap through the user manually. This table shows how the various concepts are rated. As you can see from this, design C is the highest graded and is chosen. The chosen design works the same way as described in concept C. One modification has been added. A cup holder was added in the side to give our product a wider range of versatility. The funnel allows for a single entry of fruit into the juicer as well as a storage place for additional fruits. The gears are the main means by extracting the juice, and each gear is connected individually to a motor. The filter can be seen in the diagram below to remove medium to fine particles of the juice. Two identical switches are placed on the device. One is for turning on and off, and the second is to choose which part of the container do you want your selected juice to flow. As our unique design will allow for the user to juice and store two different types of juice in one. The container with two compartments are shown below. The taps are also built into the body. The diagram shows stable cup holders that was added to the side of the design to improve its versatility. This slide shows our completed design in various views. The top diagram shows the top view. The diagram on the extreme left shows the frontal view. The right side of the machine is shown by the middle, and the left side is shown by the extreme right view. This slide shows some of the references we used in this project.